In section 3.2, we're going to talk about the algebra of continuous functions, and it's going to look very similar to previous sections, such as the one on the algebra of limits of functions, and even before that, the limits of sequences. The algebra of sequences. Okay, well, this first theorem we're going to look at, it's an extension, or maybe it's analogous to Theorem 2.4, the algebra of limits of functions. And it says that if f and g are both functions on domain D going into R, if they're both continuous at x naught, which has to be in the domain, then the sum of the functions is continuous at x naught, the product of the functions is continuous at x naught, and the quotient f over g is continuous at x naught, provided that g of x naught is not equal to 0. Remember that the domain of this function is capital D, then remove all of the points where g of x would be a 0. All right, we're going to prove each of these three. The first two are really quick. I'll probably write out the proof and then erase it and go on to the proof of 2, and then we'll go on to the proof of 3. Okay, so the first one. We know that f and g are continuous at x naught, so we have to prove that f plus g is continuous. Well, we're not going to use the delta epsilon proof, which would be very, very simple to do. We're going to use sequences instead, which is probably just as easy, I would say. Let's start off by saying, let's let xn be a sequence in D, the domain, that converges to xn. So I'll say such that xn converges to x naught, x0. Well, we've got a sequence in x that converges to x naught. Since this is continuous, by theorem 3.1, f of xn converges to f of x naught. And likewise, since g is continuous at x naught, I can say and g of xn as a sequence converges to g of x naught. Now we've just got a problem in sequences. Thus, if I add these two sequences together, we've got this sequence converging, this we could think of as capital L. This one converges to capital M. So the two of them, when you add them together, are going to converge to L plus M, which is this plus that. The sequence, f of xn plus g of xn. I guess I could have written that as f plus g of xn, f plus g of xn, converges to f of x naught plus g of x naught. And I'll write down by the sequence theorem, theorem 1.8. And f plus g is continuous. And that again would be by theorem 3.1.